And welcome, students, as we continue to discuss the ArrayList class. Yesterday we got a good look at the class itself, but now let's actually examine the methods that exist within the ArrayList class. So getting started here in today's lesson, with arrays, you'll remember that the square brackets and the instance variable length are the only tools automatically provided for you, the programmer. Now, if you want to use arrays for other things, you have to write code to manipulate those arrays. Array lists, on the other hand, come with a selection of powerful methods that can do many of the things for which you would need to write code for in order to do with arrays. So, for example, the class ArrayList has a version of the method add that inserts a new element between the two elements in the array list, and we saw this in yesterday. Additionally, with constructors, so here's our first one. We have a public array list base type int initial capacity, which simply just creates an empty array list with a specified base type and initial capacity. There's also the one without an initial capacity. And what this does is when you create this array list, it's going to specify it to 10. So if you do not specify a default size, by default, that array list size is set to 10. Now you also have array-like methods, which the first of which is the public base type set. All right. So this is takes your index and the base type of the new element. So it sets the element at the specified index to the new element, returns the element previously at the position, but the method is often used as if it was like a void method because you're not expecting a return. Now, if you draw an analogy between the array list and an array A, this statement is equivalent to setting A of index to the value of new element. The index must be a value that is greater or equal to 0 and less than the current size of the array list because it has to know where is it going because remember, just like an array, it starts at position 0. Now, it will throw an index out of bounds exception if the index is not in this range. So let's say your range was 0 to 5 and you say point to position 6, you're going to get index out of bounds exception because 6 does not exist. There's also public base type get. So the first one's our set method. This one's our get method. This returns the element as specified index. This statement, of course, is analogous to returning A of index for an array A. The index, of course, must be a value greater than or equal to 0 and less than the current size of the array list. And just like with the set method, it will throw an index out of bounds exception if the index is not within the given range. So the first one is a set value, changes the given value. Remember, it doesn't insert new values. It just changes it, and then get is simply just going to tell you what value is at that position. Now, if you want to add elements to an array, of course, we have the add method, which is a base type of new element. Adds the specified element to the end of a calling array list and increases the array's list size by 1. The capacity of the array list is increased if that is required. So if you need to make it bigger, it'll do it. Now, it returns true if the add is successful. The return type, of course, in the note is Boolean, but the method is typically used as if it was a void, because even though it says public Boolean add, it's really, even though it can return true or false, it's not actually being used like that. We're treating it actually more like it's a void method. Now, of course, there's also a void add, which has int index and base type index. You'll notice the difference with this one. It's pretty much identical, except it inserts the new element as an element in the calling array list at a specified index. So it's giving a specific value where we want to insert it. Right? Each element in the array list then with an index greater than or equal to index is shifted upward to have an index that is 1 greater than the value it had previously. So pretty much the difference between the two of these, remember, by default, it's going to add it on the end if you just use add. If you use the second add, which is the void one, that one allows you to insert it, for example, into the middle of your array list. Now, if you want to remove elements, of course, you do have the public base type remove int index, which simply just deletes and returns the element at the specified index. So it can just pull that value out. And we saw that in the demo of the array list yesterday. Each element in the array list with an index greater than index is decreased to have an index as 1 less than the value it had previously. And the index must be a value greater than or equal to 0 and less than the current size of the array list. So if your array list is, let's say, up to 5, and you say, I want it to take out value 6, you're going to index out of bounds exception there because, again, it's not in the range. And then we also have a protected void remove range. And the difference between this one and the previous one is that this deletes all the elements with indices such that from index to I to index, which means, in other words, let's say I want to delete, let's say, values from 2 to 4. I don't have to use remove 2, remove 3, remove 4. I can use remove range and take out a whole bunch of indices at once. So it gives me a lot more power and flexibility because I can just take a whole chunk right out of my code. Of course, you'll notice that elements with indices greater than or equal to the index are decreased appropriately. Now, we also have the just a public boolean remove object of the element, which simply just removes one occurrence of the element from the calling array list. If the element is not found in the array list, then each element in the array list with the index greater than the removed element's index is decreased to have an index that is one less than the value it had previously. So the purpose of this one is if you're looking for a specific object there, this is how you can remove that value. Whereas like this previous remove, this one is removing it at a specified index. This one is actually looking more for the value itself that might be stored there. And it's going to search, of course, across it and just remove an occurrence from it. Then, of course, you also have public void clear, which this is pretty much like the big fancy reset button. It removes all elements from the calling array list and sets the array list size to 0. So if you want to completely nuke your array list, use the clear, because that's what it's designed for. It's designed to nuke the array list from orbit and set it back to 0. Now, you, of course, have some search methods. If you want to search your array list, you can use the contains, which is going to search to see if it contains that value. So this is kind of like how the last remove method worked. It's going to search the array list to find something, and it returns true if it contains it in that array list and false if it does not. And then, of course, we have index of, which simply is going to allow us to tell us where in that array list is a value located. So if it was let's say it's looking for the integer 5 and it finds it at position 3, it's going to tell me that it's at that position. And then, of course, last index of, whereas like the first one just tells us the first position. If I had like multiple 3s in there, I could use last index of to search from the end of it rather than from the beginning. And of course, both of those will return a -1 if it does not find that target. Now, there are some things to talk about with memory management. Of course, you have the is empty, which simply just returns true if the array list is empty, which it means it has a size of 0. Otherwise, it's going to be false. We also have the public int size, which simply tells us how many elements are inside of the array list. We have the public void ensure capacity and new capacity, which simply just increases the capacity of calling array list if necessary in order to ensure that the array list can hold at least that new capacity of elements. The thing to note is that using ensure capacity can sometimes increase efficiency, but its use is not really needed for any other reason, because remember, it will automatically increase the array list size for us, but this is something that we can do to kind of make our code a little bit more efficient. And then, of course, we also have trim to size, which simply just trims the capacity of the calling array list to the array list size, which again can be used to save storage space, because let's say you made an array list of 100 elements, but you only ended up using 25, you could use trim to size, and that will cut it down to an array list of size 25. Of course, if we want to make a copy, we can just use a public object to array, which returns an array containing all the elements on the list, and it preserves the order of the elements. You also have public type to array, which passes in type array of A, returns an array containing all the elements on the list, preserves the order of the elements, and type can be any class types. So if the list will fit in A, the elements are copied to A and A is returned, and the elements of A that are not needed for the list elements are therefore set to null. If the list will not fit in A, well then obviously a new array is created. We also have public type, type array to array, type array A. This one's a little bit more confusing to look at. We're not really going to worry about this one too much because I haven't really explained how to handle this type of parameter syntax, because you can see we have this new kind of syntax right here because it's not something that we're familiar with like our other examples. And of course, we have the public object clone, which returns a shell copy of the calling array list. Now remember, a clone is not an independent copy, so subsequent changes to the clone may affect the calling object and vice versa. Of course, what good is it to do all this stuff if we can't check for equity? You, of course, can use a equals, and it just says if an array list of any base type is true and only true if they're both the same size and they contain the exact same list of elements in the same order. So if, let's say, the first one was an array list of integers 1, 2, 3, 4, and the second one was a list of integers 1, 2, 3, 4, they're the same size, they contain the same elements in the same order, it would return true. Now, if the second one was 1, 2, 3, 4, 5, well, now we have one more element, and technically it contains a different list, so it's not going to be equivalent. So another thing to ask is, why are some parameters of type base type and some are others of type object? Which is a very good question. You'll notice on those methods when we look at them, in some cases when a parameter is naturally an object of the base type, the parameter type is the base type. But in other cases, you'll notice it's type object. So for example, we look at the add methods and the second remove methods. The add methods have a parameter of base type. The remove method has a parameter of type object. So why might there be a difference in those parameter types? Well, the class ArrayList implements a number of interfaces, all right, that we don't necessarily have to worry about because it's, again, built into the Java libraries. It inherits methods from various ancestor classes. So this is a whole derived and base class thing going on. Now, these interfaces and ancestor classes specify that certain parameters have to have type object. So that's why we can't use base type. So for example, if you recall back in programming 2, we explained that the parameter for the equals method is always of type object because the method heading is inherited from class object. Now, in other cases, the designers of the array class were free to specify the parameter types for the method. But in some cases, of course, it was dictated it has to be an object type. So that's why if you look at it and you say, okay, why is this object and the other one's base type? That's why. All right, now we can't really sway away from ArrayList without talking about the for each loop. We'll cover eventually a family of classes known as collections in a later chapter. The ArrayList classes are our first example of collection classes. All right, so starting back in version 5 Java, added a new kind of for loop that can cycle through all the elements in a collection and can, in particular, cycle through all the elements in ArrayList. This new type of for loop is called a for each loop or an enhanced for loop. A for each loop can be used to cycle through all the elements in an array. Now, the for each loop was introduced, if you recall back with their use of arrays, all the way back in programming 1. We touched on it a little bit. Now, for example, if we look at this following code, you'll see that it ends with a for each loop that outputs all the elements in an array list named mylist. So we have array list string, mylist equals new array list string 20, some code to fill it, for string element, colon, mylist, system.out.println element. All right, all this says is for the string element within mylist, output element. So you can read that line beginning as for each element in mylist, do the following. You'll note that the variable element has the same type as the elements in the array list. It needs a match. Now, the variable, in this case, element, must be declared in the for each loop as we have done. So you can't have it outside of it. It has to be declared within the loop itself. If you attempt to declare element before the for each loop, you're going to get a compiler error. All right, that's just not how for each loops are constructed. I know with regular for loops, we can technically do it inside or outside loop. With a for each loop, you do not have that flexibility. The general syntax, therefore, for each loop statement is for base type variable, colon, collection object, and then you have some kind of statement. Now, be sure to notice that you use a colon here, not a semicolon after the variable. You may use any legal variable name for the variable. You don't have to use element. So if you wanted it to be stuff, you could do that. Now, obviously, you want to try and make it relevant. You can't just call it whatever you want because it's going to be confusing after a while. Now, although it's not required, the statement typically has in some fashion the variable. Like in ours, it was just a system.out.println of element. That's all it was. Now, the only collection objects we have seen technically so far are that of arrays and that of the ArrayList objects. Now, when the for each loop is executed, the statement is executed once for each element, therefore, of the collection object. Now, more specifically, if we think about that, that means each element of the collection object, the variable is then set to the collection element, and then the statement is executed. So every element it goes through, it's calling that statement for each element. All right, and that's going to wrap up the note side of things. Let's go ahead and just quickly pop over to Clips to give you a quick demo. So this is a very similar one to last time, but you notice it's demo 2. And here I have an array list called to list, and it's set to size 20. Enter list entries when prompted. I have done, set to false. Next, it's going to, of course, use a scanner to get those in. It's going to ask me to input entry. And what it's going to do, it's going to ask me for more items for the list. I'm going to hit yes. It will loop back. Otherwise, it's going to be exiting out. And then here it says the list contains. And you can see right here is my for each loop, string entry, to-do list, system.println entry. So let's go ahead and execute that code. I need to go to ArrayList demo 2. There we go. So this, of course, is pulling in a list of strings. So let's just put some words in here. So let's just say hello. More items for this. Yes. So computer. Let's say yes. Science. Let's just say no. And you can see it prints out the list contains hello computer science. So that right there is our list. And you notice, of course, remember, this is a original size 20, but it only contained those 3 items, which is, again, one of those strengths of an array list. All right, so hopefully that gives you some more tools in your toolbox when you're working with ArrayList. And with that being said, folks,